AFM Indicators Standard 1.02. We're working with the normal distribution this time. This is one of my personal favorite topics to teach. Let's get right into it. So, with the normal distribution, basically this just says we have a collection of data points. And with the normal distribution, we say that those data points are distributed about like a bell-shaped curve. And in this data set, the mean and the median and the mode are all the same. So here in the middle, we're going to have our mean, or what we call X bar. So this is the mean. Anytime you see the X with a line over it, it's the mean. Okay. And then we have here, we have the mean plus one standard deviation. We're going to say SD equals standard deviation. Okay. Standard deviation. All right. So then we have X bar plus 2 standard deviations. And then we have X bar plus 3 standard deviations. On this side, we have X bar minus 1 standard deviation. We have X bar minus 2 standard deviations. And then we have X bar minus 3 standard deviations, okay? That probably doesn't mean much to you right now, but let's go ahead and read the problem. It says the number of pages a print cartridge can print before needing to be replaced is normally distributed. The mean for a certain printer cartridge is 480 pages before needing to be replaced, with a standard deviation of 20 pages. A large office building places a bulk order for 300 of those print cartridges. Okay, so the first thing we want to do is we want to take the mean value and put it right under this middle line. And in this case, it says the mean is 480 pages. So we're going to put 480 there. And then it says it has a standard deviation of 20 pages. So if you notice here, I have the mean plus 1 standard deviation. So that's 480 plus 20, which gives you 500. The mean plus 2 standard deviations would be 520, and then this would be 540 there. So all I did was I started out with the mean, and whatever the standard deviation is, I'm just adding it each time. So the standard deviation is 20, so plus 20, plus 20, plus 20. On the left side, I'm going to subtract 20, so I get 460, 440, and 420. So this is the mean, 480 minus 20, 480 minus 40, 480 minus 60. Now, the normal distribution curve tells us that within 1 standard deviation of the mean, 68% of those data points lie. So here we have percentages. 34% of the data points lie right there within 1 standard deviation of the mean. And then we have between 1 and 2 standard deviations of the mean, we have 13.5% on both sides. I'm sorry for that bright green. And then here, between 2 and 3 standard deviations, we have 2.5% of the data points. Okay? So now, part A says how many of the 300 print cartridges should be expected to print between 460 and 500 pages before needing to be replaced. Well, that's going to be some simple mathematics now, because between 460, so 460 is here, and 500. So if we notice that 34% plus 34% is 68%. So what this says is 68% of 300 cartridges will print between 460 and 500 pages. So if we just take that 68%, multiply it by 300, we will simply get 204. Okay, so 204 of those cartridges will print between 460 and 500 pages. Part B says how many of the 300 print cartridges should be expected to print between 440 and 520 pages. So we're going from 440 right here to 520. So we're just going to add up all these percentages in here. So 34 plus 34 plus 13.5 plus 13.5. Well, the formula tells us that 95% of the numbers in a normal distribution are within 2 standard deviations of the mean. So as you can see here, this is minus 2 standard deviations. Here at 520 is plus 2 standard deviations. So that's 95% times 300, and we would get 285. With this particular example, you want to make sure that you set up your bell-shaped curve and you write your percentages. As long as your percentages are correct and you put your mean in place and you add the standard deviations on the right side, subtract the standard deviations on the left side, after that, the mathematics is very, very simple for these type of problems.